Okay, yes, you welcome me to the lesson. I hope that you tried out that number there. If I've told you that you got 14 is actually not the correct procedure. Are we looking at Surds? We said last time that Surds is all about expressing a number under a root. In other words, there are some numbers that do not have what we call a square root. I mean, in other words, like for example, the square root of 4 is equal to a 2. So if you cannot express the square root of a number as a fraction or as a whole number or as a recurring decimal, then you call that one a rational number. So such information, they will always use what we call the word surds. So in case we have, for example, this number here, find the square root of 200. On the calculator, I know you've just used the calculator, but the question was saying that simplify. So you have told me that what you got is 14.1241356 and so on. That means that you used a calculator. So what I expected you to do was simply to express that number in terms of maybe you simplify it in that you have one number that is under a root and then another one which is outside the root. In other words, last time we said that in case you have such a number there, try to multiply it with another number. Try to get two numbers whereby one has a square root. So in this case here, we said, for example, you can simply say that this is the same as the square root of 2 times 100. Why am I choosing 100? It's because 100 has a square root, which is 10. And then 2 does not have. In other words, you cannot express square root of 2 as a rational number or as a recurring decimal or as a fraction. So simply leave the square root of 2 under a root. So this is the same as a square root of 2 times the square root of 100. This is the same as square root of 2 times 10. This is the same as 10 square root of 2. So that is the answer that I expected you to have written. In summary, last time we summarized our lesson by saying that when you have a square root of a times the square root of a, you get the square root of a squared. When you have the square root of a times the square root of b, this is the same as square root of ab. In other words, multiply them. When you have a square root of maybe a out of b, this is the same as the square root of a, the square root of b. When you add or subtract, for example, you have a square root of a, sorry, of b, plus a square root of c. We say that this one is as if you have a square. No, there's let me just use this. Let's use this one as a square root of c. Let me just use that. Plus b square root of c. For this one here, we say that just look at what is under the square root. It is a common term. In other words, we factorize it out. So this will give us square root of c into brackets a plus b, like that. Or in case you have a square root of c and then plus a square root of b, it is the same thing here. This a is a common factor. So you can factorize it out and then you have a into brackets square root of c plus square root of b. In other words, when you're adding figures under a root, like these ones here, this one is different from this. So you cannot express the two outside. I mean the multiplication under, multiplication is not the same as addition. That's what I'm trying to say there. So that is what we had last time. So this morning we're going to be looking at another term, and that is called rationalizing the denominator. Rationalizing the denominator. What does it mean to say that we're going to rationalize the denominator? It means this. Let me go to the next page here. So rationalizing the denominator. You can write this somewhere. It means removing the square root sign. The square root sign from the denominator. For example, you can say that rationalize A out of square root of B, like that. Rationalize the denominator. So when you rationalize the denominator, it means that you're going to remove the square root sign from the denominator. In case of being given a fraction like that, and then saying that to rationalize, you can see that in the denominator there is a root of B. So what we do there, we know that when you get, for example, 2 under a root times 2 under a root, this is the same as the square root of, this is the same as a 2. When you have, for example, I'm just giving an example before we go to the solution to our question. If you have, for example, a square root of 4, when you multiply it with a square root of 4, the answer here you're going to get is a 4. In other words, what is the square root of 4? It is a 2. What is the square root of a 4? It is also a 2. So this is the same as a 4. 2 times 2, you get a 4. So what I'm doing there is just that I'm removing this square root sign here. Meaning that what we're going to do in the denominator, in case you have an expression which is under a root, for example, square root of B, in case you're going to remove that square root sign there, minus changing what the question does, we are going to simply multiply the square root of the B, in other words, the whole denominator, by itself, and we also multiply it with the numerator. In other words, this is what we do. We shall say that we have A out of the square root of B, and then we multiply the denominator by the square root of B, and the numerator also by the square root of B, like that. So this will give us A times the square root of B, and the square root of B times the square root of B, which will give us A square root of B divided by a B, like that. And that becomes our answer. In that final expression there, we can see that there's nothing like a square root B in the denominator, and that is what we call rationalizing the denominator. Okay, you can first copy that, then we get more examples. You can first copy that. Okay, we can now have live examples, more examples here. So examples number two, we can say rationalize the denominator. In the expressions below. Part A, we can have 1 out of root of 2. So we're going to remove the square root sign from the denominator, but without changing anything. Without changing anything. So still here, what we do is very simple. We shall say that this is the same as 1 under a root. So multiply the denominator times itself. What you do in the denominator is what you do in the numerator. So this is the same as 1 times the square root of 2. Denominator root 2 times root 2. So this is the same as 1 times square root of 2 is the same as a square root of 2 divided by root 2 times root 2, you get that very number which is under the root, and that is our answer there. Now you can even use a calculator and verify. When you get to 1 divided by the square root of 2, do you get the same answer when you have square root of 2 under a 2? I mean square root of 2 divided by 2, do you get the same answer? If yes, then you have changed nothing. So that is rationalizing. In the same way, try to get for me this answer here. Part B. It is 2 under root of 5. Rationalize the denominator. I'm going to wait for you.
I got a point.
You got a point?
Then, yes, up on the numerator.
Okay, what answer have you got finally? Okay, we can try to have the corrections here and we see. So I've said that in case you have only a single square root, even if it is for example a square root of b in the denominator, what you do, you simply multiply the whole of this, both in the denominator and in the numerator. So what you do here, we have for example, we have 1 times the square root of 5 in the denominator. So what we do is simply multiply 1 root 5 denominator times 1 times root of 5 in the numerator as well. But of course, 1 changes nothing. That's why it is not considered there. So here we shall say that this is the same as 2 over square root of 5. Then, if you rationalize the denominator, multiply the root of 5 times the root of 5, both in the denominator and in the numerator. This will give us 2 times root of 5 divided by root of 5 times root of 5, which will give us then that 2 square root of 5 divided by a 5 in the denominator, because we say that when we multiply the root of a number by the root of its that very number, this it changes nothing. It gives us that 5 under the root. So therefore our answer therefore becomes the answer there. It becomes 2 root 5 divided by 5. That is our answer. I said that in order to make sure that you check whether your answer is correct or wrong, you can use a calculator. You press this on the calculator, then you write down the answer. Somewhere not in the working, also this one on the calculator, and so they get the same answer. So once those two answers are the same, then we can say that you have rationalized the denominator. But in case you're sure of what you've done, there's no need of verifying your answer there. So that is part B. Let's do part C together as well. Hope that you've done the corrections there. Part C, you can have root of 2 divided by 3 root of 5. Rationalizing the denominator. So we have said that in case you don't have anything like addition or subtraction in the denominator, you're not adding or subtracting roots. You simply multiply whatever is under the division symbol to both the denominator and the numerator. So shall I say here that this is the same as root 2 out of 3 root 5. So multiply times 3 root 5 times 3 root 5. This is the same as root of 2 times 3 root 5 divided by 3 root 5 times 3 root 5 under a root, like that. Remember the rules that we had last time at the end of the last lesson, and I've just reminded you of those rules there. That, for example, in case you have root 2 times root b, you get root of ab, like that. So it is the same thing that we have here. So this is the same as root 2. We can have 3 times root 5 times root 2. I'm just trying to expand, but I'm changing nothing. In case you know what you're doing, you can even skip this step. So under a root, under the division symbol here, we shall have 3 times 3 times root 5 times root 5. This is the same as 3 times 5 times 2. Since we're multiplying, we say that when multiplying or dividing, you can put everything under the root. Divide by 3, 3 times 3, you get 9. Then times under a root 5 times 5, which is the same as 3 under the root of 10, 3 times root 10, divided by 9 root of 25. But 25 has a known root. So this is the same as 3 root of 10 divided by 9 times, so root of 25 is a 5. So our answer will be 3 root of 10 divided by 9 times 5, you get 45. And you can even reduce this. You can say that by 1, by 3 you get 1, by 3 you get 3. Such that in the denominator you have 3 times 5, which is 15. Or in the final answer still, you can simply say that by 3 you get 1, by 3 you get 15. And therefore the final answer will be 1 root of 10 divided by 15, which is still the same as root of 10 divided by 15. And that gives us our answer. You can copy that, then I give you another similar example together as well. Anything which is not clear, we can now go to part D, another similar question. It says that rationalize the denominator still. Part D, we have 2 and a root divided by 3 square root of 3, like that. It's the same way. It's the same way. Everything that we've done in part C is the same thing that we do in part D. So here we shall say that this is the same as, since we don't have anything like addition or subtraction in the denominator, then you simply multiply whatever is the denominator by itself and also in the numerator, so that you don't change anything. So this is the same as 3 root 3 times 3 root 3 root 2 times 3 root 3. So whatever you have done in the denominator is what you do in the numerator. Times. In other words, it is as if this one cancels out with this, meaning that you've done nothing. You've changed nothing. Then from here, we can say that this is the same as whatever is in the root. I'm going to skip some steps now since we already know what we're doing. So of course there is a 1 here. So I'm going to multiply this 1 by this 3, and I will get 3. And a root, I'm going to multiply this 2 and a root times this root 3 and root 3. So which is the same as 2 times 3. Divide by, I'm going to do the same in the denominator. Multiply the 3 by 3, I'll get a 9. And then this root 3 is the same as this root 3. So if you're multiplying the 2, there's nothing that you change. Or you can even multiply them times 3 times 3. So this is the same as 3 root of 6 divided by 9 square root of 9. In other words, times root of 9. So this is the same as 3 root 6 divided by 9 times root of 9 is 3. From that point, you can say that this 3 cancels with this 3. So the answer will be equal to 1 root 6 divided by a 9. And that is our answer. Or you can simply write it as root 6 out of 9. And that is our final answer. So likewise, I need you to try out with this, then we go to we advance to another stage. Try out to root 5 divided by 2 root of 2. You try out that as well. So I'm waiting for you. When you're done, you let me know. Actually, we have 10 minutes left to the end of the lesson. We started a little bit late. You try always to start on time, such that we cover a lot. Because at 10 sharp, there's always another class. Okay. What answer have you got? What answer have you got?
1 square root 10 out of 4.
1 square root
10 out of 4.
Out of 4. Okay, let's do it together and we see. Let's do it together and we see. So this is the same as root 5 2 root 2. So we multiply in the denominator times, use a different color, times 2 root 2 times 2 root 2. So this is the same as 2 root 2 times 2 root 2. And in the numerator have root 5 times 2 root of 2. Okay. So this is the same as I said that there is a 1 here. So you multiply 1 times this 2, you get 2. And under a root times under a root, this root 5 times root 2 shall have 5 times 2 under the same root, divide by 2 and this 2, you multiply them. So you shall, in other words, have 2 times root 2 times root 2. Remember that. So you multiply the same figure, root 2 times root 2, you get 2. Meaning that our answer here will be equal to, in the numerator shall have 2 root of 10. Divide, let me write up here because the space has jammed. Let me write above here. Let me write up here. So I'll simply have 2 root of 10, and here I'll have 2 times 2, I have 4. Times 2 here, I'll have 8. I'll have, in other words, root 2 times 2, you get 2. So meaning that I will have my answer here as 2 times 2 times 2. And one of them can cancel out, 1, 1. And the final answer will be 1 root 10 divided by 4, the answer that you've got. You can still write it as root 10 out of 4. which is very correct. Okay, so at the moment, I need you to try out for me this 3 root 7 divided by 2 root of 5. Try out this, and then you send me the answer on WhatsApp. You take a picture, then you send me the answer on WhatsApp. I'm going to send some of 5 numbers or 6 numbers in the Google class. You try them out, please. This time around, you attempt and you send in the Google class. In case you find challenges, you let me know. Otherwise, at the moment, try out to this, and then you send me on WhatsApp. Next time when we meet, we shall be looking at questions like, for example, a plus b divided by a plus root of maybe bc. Rationalize the denominator. In other words, we shall be looking at expressions where you have addition or subtraction in the denominator. Otherwise, I'm stopping there for now, and I'll say that have a great day.
Okay.